Okay, so this is example 2 from chapter 14 from Giancoli. We're now back to getting rid of all the cake and ice cream. Now we're actually going to do some calculations here. So what we want to know is we've got what do we have? An empty 20 kilogram vat made of iron. We want to raise it from 10 degrees to 90 degrees, so we're going to figure out how much heat we have to put in. And then we're going to calculate how much we'd have to add if it was filled with 20 kilograms of water. So we've got 20 kilogram vat plus 20 kilogram water. So let's just do the calculation for each of them. So how much energy do we need to raise a 20 kilogram vat of iron from 10 degrees to 90 degrees? Okay, here's our formula. The heat is equal to the mass times specific heat times the change in temperature. Here's our table 14.1. We can see that iron or steel has 450 joules per Kelvin degree C. So that's what we're going to use for our C. So let's calculate this. So that my Q, the heat I have to add, is, well, we've got 20 kilograms times the specific heat, which is 450 joules per kilogram degree C, times my change in temperature is going to be, final is 90 degrees. Let's see, 1 sig fig, 90 degrees Celsius minus 10 degrees Celsius. Okay, so we multiply that together. We have 20, 450 times 90 minus 10 times that. So we have 720,000 joules, 720 kilojoules to heat up the iron. Oh, let's make sure we got the units right. See, kilograms cancel, degrees Celsius cancel with those. Yes, we have joules, so 720 kilojoules. And 2 sig figs is probably more than we have, but that's okay. How about if we're heating the water? How much heat do we have to put in? So for that one, so this will be, that's water. This is, what is it? Iron. Iron, O, and I. There we go. There's my heat for the iron. How about for the water? Well, mass is going to be 20 kilograms again. We're going to use the same formula. But in this case, we have to use specific heat of water, which is almost our definition, is 4186 joules per kilogram that we have to put in, degrees C. Why is it not 4.186? Well, I'm doing per kilogram, so that's why it makes that a little easier. Multiplying that times my 80 degrees, which is 90 minus 10. We've done that already. Degrees C cancel, kilograms cancel. Okay, so let's figure this one out. So we have 20 kilograms, 4186 times 80 degrees, and let's say, so it's, oh, I don't know, 66976. You can see that. Got way too many sig figs there. But we probably have, let's say we have 2 sig figs, so we round to there. Is that a 5 or greater there? Yes, it is. So this becomes 6.7 times 10 to the, whoop, look at that, 6 joules, or 6.7 megajoules. Can you still see that? I'm hoping you can still see that, megajoules. So this is 724.72 megajoules. That's 0.72 megajoules. So this is 10 times the energy to heat up the water than the iron. But if we want to figure out how much energy we need for both, we just add them up. So that's how we do it. We do the Q total that we need to heat that up would be 6.7 times 10 to the 6, 0.72 times 10 to the 6, just making sure they're the same power, would be 7.4 megajoules. So that's how we calculate that one.